Oh, so this is the questions and answers about natural computation. This is the video 2. And the issue here is the particle swarm optimization algorithm. So the question is, in the context of the particle swarm optimization, consider 4 particles randomly initialized in the two-dimensional space that can communicate with each other. Explain the meaning of personal bests and global best, and describe in general how the particle swarm optimization works. So, as before, I'm going to stick this just this question into the NoteBookLM from Google, and we are going to see the result. I'm going to play the video so you can see it.
Okay, so what if I told you the best way to solve a giant, complex problem wasn't with some genius leader, but with a team that has no leader at all? What if the solution could be found just by following a couple of simple teamwork rules? Well, today we're going to dive into a really powerful idea that does exactly that. To really get this, I want you to imagine something. Picture this. You're standing in a massive valley, and it's completely filled with a thick fog. You just know there's a highest peak somewhere out there, but you can't see more than a few feet in any direction. So how on earth would you find it? It sounds almost impossible, but it turns out there's a surprisingly elegant way to crack this puzzle. To solve it, we're not sending in some lone wolf hero. Nope, we're sending in a team of 4 to be exact. And these aren't, expert mountaineers with years of training. They're just a group of explorers who happen to be able to talk to each other. But here's the twist. We basically drop our 4 explorers into this valley at totally random spots. They've got no map, no compass, not a clue where the peak might be. It's just chaos. So where do they even start? Well, they pull it off by following just 2 super simple but really, really powerful rules. And these rules are all about balancing what they figure out on their own with what the team discovers together. So the key here is understanding the 2 different kinds of knowledge they're working with. On one side, you have each explorer keeping track of their own personal journey, but on the other, the entire team is instantly aware of the single best discovery made by anyone in the group. Let's dig into that a little more. First up, personal best. This is pretty straightforward. Think of it like your own personal high score in a video game. As an explorer is walking around, they're always keeping track, thinking, okay, what's the highest spot I've personally been to so far? That spot, that's their personal record. And then you've got the global best. And this is where the teamwork really kicks in. It's all about communication. At any point, one of our explorers can just yell out, "Hey everyone, I'm at 500 feet." And if that's a new record for the whole group, boom, that becomes the new global best, and everybody instantly knows about it. So what this all boils down to is a really simple, powerful philosophy. Trust your experience, but learn from the group. Each explorer is guided by both their own memory and the success of the team. It's this perfect dance between individualism and cooperation. Okay, so that's the theory. But how does this actually turn into a strategy? How do these 2 bits of info, your personal best and the team's best, tell an explorer where to go next? It's actually a really simple little loop that just repeats over and over. Every single moment, each explorer is basically being pulled in 2 directions, right? They're thinking about the best spot they've found, but they're also thinking about that big global best the team found. Their next step is going to be a leap somewhere in between those 2 points. Then they check their altitude, and the whole process just starts again. You can almost boil it down to this simple idea. My next move is just a mix of my own best discovery and the team's best discovery. And this is so clever, right? Because it stops any single person from just getting stuck wandering in a low spot. It forces everyone to learn from whoever is having the most success at any given moment. All right, so what's the end result of all this? What happens when our team just keeps following these simple rules over and over and over again? What's the big payoff for thinking like a team? Yeah, let's not forget where we started. 4 explorers just scattered randomly in a foggy valley. No plan, no leader, just complete disorganized chaos. And yet, look what happens. By following those 2 simple rules, something amazing emerges. The group starts to move together. They go from just wandering around to zeroing in super efficiently on the highest peak in the entire valley. They solve the puzzle, and no one ever had to be in charge. So this little story we've been telling about explorers in a valley, it actually has a real name in the world of computer science. It's called particle swarm optimization, or PSO for short. And in the real algorithm, our explorers are just called particles, and the foggy valley can be any complex problem you're trying to solve.
And look, this isn't just some cute thought experiment. PSO is used all over the place in the real world. We're talking about training AI, designing more efficient jet engines, solving all kinds of incredibly difficult problems. The whole idea was actually inspired by watching nature. You know, how a flock of birds or a school of fish can move in perfect harmony.
Which brings us to a pretty mind-blowing final thought, right? If a few super simple rules can lead to this kind of complex, intelligent behavior from a group with no leader, it really makes you wonder, what other huge, foggy problems could be solved if we just learned to think a little more like a swarm?
So,
Okay, so
no, not bad. So about this generated video with AI. Okay, it's just about the basic concepts. You got the idea. So in this sense, okay, this is a good video, but no equations representing the dynamics, the velocity and position, the inertia, etc. So in this sense, you have to watch more videos with details, no equations here. Okay, so I hope that you like it.